This short tutorial will explain about bone functional adaptation. I would like to start by saying that bone functional adaptation happens both in cortical bone, which is the outer cortex of bones, and inside the trabecular bone, which is the spongy structure that resides inside the extremities of long bones and inside short bones. I also want to stress that this image here that you see is a very simplified schematic 2D view with a much more complex 3D view or 3D structure of the trabecular tissue and the cortical bone. So in this view here, this example here, we have a simplified view of a vertebrae, which is the bone or one of the bones inside the vertebral column. And usually the bone is loaded in a very specific direction along the axis from adjacent vertebrae. So the direction of loading is straight downward in this example. And because this is the typical loading, the bone experiences it daily and it is adapted to that type of loading. So what we see here is in blue is the level of strain or deformation of the bone. And the level of deformation under typical loading will be not too high and not too low, somewhere in the middle, which is called a steady state, which means at that situation, the bone doesn't feel any need to add more bone to accommodate high strain, high deformation, or to resorb bone because the bone is excessive and we don't need so much of it. But let's say now that something happens and we are starting now to load our bone in a different way. So this is represented by this direction of the arrow. And I want to stress here that the point is that this is not a one-time thing. This is a constant change that occurs and continues throughout time. Now, the previous structure is not adopted or optimized to that new direction of loading. And the direction of load transfer is represented by this dotted line. So you can see that it goes somewhat in midair because there is no bone tissue in there. This will cause some area of the bone to experience very high strain, like in this example, the red lines here, and other area will sense very low strain, represented by the green area here. With time, bone cells, osteocytes that sense the changes in strain inside the bone will recruit bone resorption cells that are called osteoclast or bone depositioning cells that are called osteoblast, and they will slowly either erode or resorb bone in area where the strain was low and deposit bone in area where the strain was high. And again, this is a continuous phenomenon or process that takes weeks and even months. But eventually, what will happen is that the new architecture or structure of the trabeculae will again align itself to the new direction of loading, and we assume again a steady state. I want to again stress the point that this is a very simplified view of bone functional adaptation. Obviously, in real life, the trabecular structure is 3D. It's never aligned so nicely as you can see here. And there are other components and contributors that may affect the process. But this is the concept of bone functional adaptation. This is an example in cortical bone, where you can see that was an experiment that was done about 20 years ago. They were loading the right forearm, sorry, the right leg of a rat. And the right one was loaded several times a week for a couple of weeks, while the left leg of the same animal was unloaded. And they used some bone staining materials that were ingested by the rat throughout the experiment that will highlight the new bone that it is being deposited. So you can see that in the left leg, which was not loaded, there is very little bone added. So that red line is the line that explains or that shows the beginning of the experiment, and anything that is outside of that line is new bone. So there's very, very little happening here. Look what happens here on the right limb, which is loaded. There is a lot of new bone. That is the bone functional adaptation. The bone reinforces itself, add more bone to withstand the higher deformation that that leg experienced during the loading experiment. So as I mentioned, this phenomenon of bone functional adaptation can happen both in trabecular bone and cortical bone. Trabecular bone, because of its higher surface area, is more sensitive and can give us a better signal of the direction of loading, not just the fact that loading happened. I mentioned that the cells are the ones that are experiencing the changes in strain and recruit other cells. So this is, again, a schematic view of what happens. So we have bone tissue here. We have osteocytes. These are the bone cells that are sit inside the tissue and are sensory. And during steady state, when they just feel regular deformation, they don't deform much, and therefore they don't send any signal to cells which sits on the surface of the bone, and their function is to eventually recruit other cells. So this is a steady state, and nothing really changes here. However, if for some reason we increase the load, so before we had only one arrow, now we have two arrows. So now the load is much bigger. Osteocytes will deform more, and they will send a signal to osteoblasts, bone depositing cells on the surface, and these bone will add new bone. You can see it by this darker area here. And now, because the area or the volume in 3D is bigger, the same amount of loading is distributed over a larger area or volume, and therefore it goes back into steady state. On the other hand, if, for example, where there are areas with have less loading, like in this case where we have this uneven or staggered arrows, the osteocytes will feel less deformation, less strain, and this time they're going to recruit osteoclasts, bone resorption cells. They will resorb some of the bone. As you can see here, there is less bone area or bone volume, and now the same amount of lower stress, lower load is distributed over a smaller area or a smaller volume, and therefore the amount of deformation that each unit of cell feels goes up, and we're back into steady state. So that behavior of bone resorption and bone deposition, depending on what the osteocyte sense, will in time change the structure of bone, both cortical bone, but more so trabecular bone. And that is the key idea of bone functional adaptation.